Hello everyone. Today I am going to present our project Network Intrusion Detection using Machine Intelligence. This project has been carried out by me, Srijita Nath and Pratyush Nandi under the guidance of Dr. Mohananandi Pal and Ms. Anusha Bera. In this presentation, we will discuss how machine learning techniques can help improve intrusion detection system and provide better cybersecurity solutions against modern network attacks. Distributed denial of services or DDoS attack are one of the most common dangerous threats. These attacks overload network resources, reduce performance, and can even make service unavailable to users. Traditional intrusion detection systems mainly use signature-based detection method. Although they are useful for known attacks, they struggle to identify new or unknown threats and often produce high false positive rate. To overcome this limitation, our project proposes a machine intelligence based intrusion detection system that can automatically classify normal and malicious traffic using machine learning techniques. For this project, we reviewed several recent research papers related to intrusion detection systems. The first paper proposed a hybrid machine learning and deep learning model using random forest, ANN, CNN, and XGBoost for intrusion detection. The study achieved very high accuracy, but the authors mentioned possible overfitting and dependence on benchmark datasets. The second paper focused on ensemble-based machine learning techniques such as random forest, AdaBoost, gradient boosting, and XGBoost. Random forest showed the best performance among all models. The third paper used stochastic gradient descent and dimensionality reduction techniques for wireless sensor network intrusion detection. These studies help us understanding existing approaches and their limitations. Other papers explored intrusion detection in IoT and medical IoT environments using federated learning and energy-efficient models. Some studies uses oversampling, PCA, and feature extraction techniques to improve accuracy and reduce false positives. However, many of these approaches have limitations like high computational complexity, lack of real-time validation, dependency on labeled datasets, difficulty handling evolving cyber threats. These research gaps motivated us to develop an efficient machine learning-based intrusion detection system. Methodology consists of multiple stages. First, the dataset was collected and pre-processed. Next, important features were selected using random forest and SAP analysis. After feature selection, level encoding and classification was performed. Finally, different machine learning models were trained and evaluated using performance matrices like accuracy, precision, recall, F1 score, and confusion matrix. This complete workflow helps us compare different models effectively. We use the CIC DDoS 2019 dataset created by Canadian Institute for Cybersecurity. These datasets were designed specifically for intrusion detection research and contains multiple DDoS attack scenarios. In our work, we focused on the LDAP traffic file. This dataset has more than 2 million network flow records and 18 flow-based features. The traffic is labeled into three classes: benign, LDAP, and netbus. The diversity makes the dataset highly suitable for evaluating intrusion detection models. Data preprocessing is a very important step in machine learning. First, missing and null values were handled carefully to clean the dataset. Duplicate records were removed to improve data quality and avoid redundancy. Non-numeric features were also removed because machine learning models require numerical input. Finally, data sampling and class balancing techniques were applied to ensure fair representation of all classes and improve model performance. To identify the most important feature, we use random forest with SHAP analysis. SHAP stands for Shapley Additive Explanations. It helps explain how different features contribute to model prediction. Some of the most important features were minimum packet length, average packet size, flow byte per second, packet length mean, and maximum packet length. Features selected help reduce complexity, improve training efficiency, and enhance model interpretability. Label encoding was performed to convert categorical labels into numerical values suitable for machine learning algorithms. We used both multi-class and binary classification approaches. In multi-class classification, the model simultaneously distinguishes among LDAP, netbias, and benign traffic. In binary classification, there are 4 experiments: benign versus attack, LDAP versus benign, LDAP versus netbias, benign versus netbias. 3 different types of machine learning models were implemented and compared in this project. The first model is random forest, an ensemble learning method that combines multiple decision trees to improve prediction accuracy and robustness. The second model is k-nearest neighbors, KNN, which classifies data points based on similarity and distance matrix. The third model is artificial neural network inspired by the structure of human brain and capable of learning complex patterns from large datasets. Each model has its own strengths and limitations, which we analyzed through experimental results. The random forest model achieved high accuracy, precision, recall, and FR score values. The confusion metric also shows that very few misclassification here indicates strong intrusion detection capability. Overall, random forest emerged as the best performing model among all three algorithms. The KNN model also achieved good classification performance. It was able to identify malicious traffic patterns effectively, but compared to random forest, it showed slightly lower accuracy and required more computational effort for large datasets. The artificial neural network model demonstrated strong learning capability and produced high classification accuracy. ANN was particularly effective in identifying complex traffic patterns and malicious activities. However, neural network draws more computational resources and timing compared to traditional machine learning models. The conclusion metrics of ANN show good classification performance across different experiments. In future, the proposed intrusion detection system can be tested using real-time network traffic instead of only benchmark datasets. We can also explore deep learning and hybrid models to improve scalability and detection accuracy. Additionally, this system can be extended for cloud security, IoT networks, and real-time monitoring applications. Thank you.